Today John discusses the good and bad aspects of the MGB Sills.
Welcome viewers. Today we're going to discuss the MGB sill, which is both an engineering marvel, but as we know, it's also a terrible Achilles in terms of rust. So first we'll talk about is the inner sill. This is the part you see from the driver's seat. It's the inner half of the sill assembly. There's an outer sill we'll talk about later, separated by a stiffening membrane. The shape of the inner sill is basically a large L with some fastening flanges for spot welds. By itself, it's very stiff in the up and down direction and the sideways direction as installed. But by itself, it's rather flimsy. It needs the support of other members. Next, we'll talk about the castle rail. This is the member that is first installed to connect the forward section of the body to the rear section of the body at the factory. It's a little bit thicker gauge than some of the other parts. It's heavily flanged and bent, so it's very strong in up and down direction and side to side direction. Since it is so rigidly installed into the structure of the vehicle, you can think of this as the foundation for the rocker assembly or sill assembly. Next we have the outer sill. By itself it's very stiff in the sideways direction, but not at all in the up and down direction. It's not until it's fastened to the other parts that it gains its rigidity, which we'll discuss later in the video. This is the part that you see from the outside of the vehicle, so it's the below the door you'll see this, and so it will be painted. And lastly, we have the inner stiffening web or membrane as it's sometimes called, and this is just a flimsy piece of sheet metal by itself, very weak from the side but very stiff in the up and down direction. But when it's installed correctly between the inner and outer sill and then mated to the castle rail, it becomes a major stiffening member, acting basically as an I-beam running right down the center of the sill assembly, giving it very high strength in all directions. There are two more parts that are part of a typical sill assembly. One is a triangular gusset shown here. You weld this in against the inner sill and against the castle rail on the bottom, and it's a triangular gusset that provides a lot of strength right above the jacking point of the vehicle. If you didn't have this in there and you go to jack the car, you can bend the whole rocker assembly if you're not careful. This last one is an interesting little piece that comes in the typical kit, and it's basically a plug that fits at the end of the outer sill, and it seals off the tube that the membrane and the outer sill make from getting debris kicked up by the rear wheels or just road debris in general. There's really not a lot about this part out there in the world. We will discuss it a little bit more at the end. There are specific times during a sill installation that you'll have an opportunity to access this in a way that you can install it correctly. Sorry ladies, not that kind of stiffness. We're going to get into math just a little bit here, but we'll keep it sane. There's two important concepts from an engineering standpoint, and that's cross-sectional area, which is pretty common knowledge, length times height. But then there's one called moment of inertia, which is a little less understood. And really, we don't need to understand it to know what's going on in parts in a car. But just know that moment of inertia is basically the resistance to bending. And it's given by this formula here. But what's important to notice about this is it's based on the cube of one of the dimensions, either the length or the height. This is the important thing to understand. So we're talking about stiffness, and in our case the MGB sills, and what makes them so stiff or so strong. It's a combination of knowing about area and inertia, and just seeing how the engineers use these to their advantage to create a very strong structure, i.e. the sill or the rocker panel, out of very thin and typically flimsy sheet metal. So how did they go about doing this? There's a couple of ways you can make things stiff or more stiff. The obvious one is to just make it thick. And here we show a thin piece of sheet metal. You could see it'd be very easy to bend that in half, so to speak. Simply by increasing its thickness, you are going to make it more stiff. But you're doing that by adding material which will make it heavier.
How do you increase stiffness without increasing weight? My lazy boyfriend needs to know.
Well, this gets back to our two equations, but basically you do it by increasing the cross-sectional area. So if we look at the next example, we're going to just simply add 2 flanges on each outer edge of that previous piece of thin sheet metal. So what this did for us was it increased the H, or the height of the part, similar to increasing the thickness, but from a straightforward calculation of area, yes, we have increased the area. But when you look at inertia and the fact that that height is cubed in this case, that's a substantial increase in that number. And that's why when you add shapes like flanges or beads or anything that causes the cross-sectional area to increase in height, you are increasing its stiffness. There's a lot more to it than this, but this is just breaking it down into its fundamentals. There's also hardening that goes on when you bend parts and things like that. So for all you purist engineers that are rolling their eyes, I'm trying to make it easily understood by the common person. Understanding this basic concept of increasing the cross-sectional area is what the entire MGB monocoque body and certainly the sills are based upon. If you've noticed, every piece of plate that's on an MGB either has a flange on its edge, it has a bend to it, or it has a bead or some type of boss imprinted into that sheet metal. All these things increase the stiffness of that particular panel. If we look at just the structure of the sill assembly, you can see it's a tube structure, which is basically a box with a thick I-beam running down the middle of it. And notice that the flanges on the top and the bottom are extra thick because they're a buildup of 3 pieces of sheet metal. This makes for a very rigid structure. The only direction this is weak in is in a shear. If you were to push on, say, the upper left corner and cause the whole thing to collapse. But given that this sill tube is fastened at each end rigidly to various parts of the surrounding structure, creates a shape as if it was a solid block like you're shown here. So again, extremely strong. So in this view, we're looking at the side view of a body frame on two supports. And if you were to look at it, you would expect it to just snap in the middle, right? The middle of it would just, go towards the ground and just buckle. But because of the rigidity of the two sill assemblies plus the transmission tunnel, makes for a very stiff structure. Now that I've sung the praises of the engineering that went into the body structure as a whole, and certainly the sills, at the same time, the engineers did a horrible job of water and moisture abatement or control. One would think or expect that the Roadster, being open to the elements, if it got caught in the rain, certainly the rain would find its way, under the carpets and into the trunks and all the places that we see the rust on the Roadsters. But it doesn't seem to be any different on the GTs. So they just did a horrible job at controlling moisture in general, because regardless of GT or Roadster, they're always rusted in the same places, which is behind the fenders, in the trunk, and certainly the sill assemblies, not to mention, of course, the floor panels. So let's take a look at the assembly of the sill, because that's what this video is supposed to focus on, and determine why they just rust out so badly, and always it seems to be in the same areas. So here I'm showing a cross section through a sill assembly, and we're going to look kind of as two compartments, the outer compartment and the inner compartment. So based on those descriptions, when I'm talking, you'll understand what I'm referring to. So for the inner section, they created a series of weep or drainage holes along the bottom edge of the castle rail, hoping that gravity would cause the fluids to migrate there and just drain out the bottom. We've shifted views looking up from under the car now at the sill, and for the outer compartment of the sill, created by the outer sill, they gave a series of weep holes or drainage holes along the edge. Here they're shown in the CAD file, and then here they're shown on an actual car. And this is supposed to handle any moisture that gets trapped in the outer sill. Alright, so where's all this moisture getting in on all the vehicles? Probably foremost is right here along where the floor pan meets the sill assembly. It sits on top of the castle rail, and there's that flange that they share. And certainly whenever it rains or condensation or whatever, moisture just seeps down along that crack and comes in, and it's theoretically supposed to just go into the castle rail trough and out those bleed holes or weep holes out the bottom. Fortunately, that's not real life. Similarly, moisture can come in right from the bottom of the car, right along under the floor pan where the castle rail meets it, and work its way right interior to the inner compartment. Okay, so this top seam is a little bit interesting. Aft of the A-pillar, not much moisture is getting in here because there's a rubber seal that goes the length of it from the B-pillar all the way to the A-pillar. However, forward of the door, as shown here, is a major culprit. You have all the water that's splashing up from the front tire going behind the fender, and there are a couple of baffles in there to stop that, but there's no way it stops at all. It's also coming in from the hood and dribbling down the side of the inside of the fender, and then it's coming in through the gap and the seam where the outer sill and the membrane and the inner sill come together on top of the inner footwell kind of side panel. And that's a major area where water is coming in, dribbling down, getting into that outer compartment and sitting in that lower area where it just can't drain out. The next area, which is a big culprit, is this edge where the outer sill meets the inner membrane and gets spot welded in place. You have all those small drainage holes in this area where moisture can come up. If you're driving on a rainy road, it is going to splash, and all the mist and droplets will work their way up in there, and they really don't have a place to go. Unlike on the inner compartment, they can kind of form in that trough and go out the bleed holes, but here, any moisture that gets in this area from any means, whether it's condensation, humidity, water splashing, you name it, wherever that water is coming in, it comes into this compartment and it just sits in that lowest portion, and that's just a spot welded joint. So moisture does get in there, it can't go anywhere, and this is for sure where 90% of the rust starts, and then it just propagates out from there. So what do we do about this mess we find ourselves in? Well, there's certainly plenty of products out there. Some of them are listed here. Some of these are the bigger ones you would come across. And they're all just some type of coating that's elastic. It can't be rigid, right? It's got to flex with the body and stay soft and pliant over time. So that's what you're kind of seeing here. And they all do a great job. Some of them you need to redo every year. Some of them are a one-time shot. So it's kind of up to you. What you feel like using is best for your situation. But keep in mind that we're focusing on the rocker assembly and sills, and so access to the inside of it is somewhat limited. You need to take that into account when you start selecting which one of these you're going to use on your vehicle. As you can see here, British Motor Heritage, which is an excellent resource for anything MGB, they actually have a guide. I guess I'll put a link to it in the front of the YouTube that shows all of the factory specified sealing locations. Again, we're focusing on the sills and rocker panels, but this shows it for the entire vehicle. All right, so as far as sealing the sill, you've seen all or where the rain gets in. So it comes, from the hood and through this area. It runs down here on both sides, collects down here, goes in through any cracks or bad welds or whatever's going on in here, comes through holes like that and settles under the carpet, goes through that seam where the floor pan is connected and ends up in here, right? And it collects right down in here. Again, there's a couple of weep holes along here, but it just is in here, right?
So that's why these are always just rotted to hell on every MGB you see. So in terms of where to seal, you just got to use common sense. I just explained the water's coming down here. It's sitting on the top of this. So, you know, for sure you want to put some here. You want to put some here. On the other side also, you want to do it the same. Maybe in here, just anywhere. Just put that shit everywhere, right? This is all hidden under the fender anyway, so who cares if you got, you know, loads of the stuff on. You don't need anything here really, or here. And again, as I said, there's a weather strip or a rubber strip that covers this whole thing all the way. Does it go all the way up? I can't remember if it goes all the way up, but certainly to here. So water getting in here is not really a problem, but as soon as you're here now, the water's coming on both sides of this panel. It's coming down here, you know, and then it might be going in here, right? And I'm for sure it is going in here. So you want to seal all that, right? That's why I have this gooped in all over here. So just know that, right? And the last thing I'm going to do, and I described this in a previous episode, but there's a little panel that goes here. Hang on, it's behind you. It comes with the rocker panel or sill kits when you buy them as a kit, with the inner and outer and the castle rail, and it all comes as one, and you get this little guy. And at first you might not know what the hell to do with it, but then you realize after a while it goes here, okay? But it goes inside, and I can get it in like that. You know, it'll go in there and I'll be able to weld it, puddle weld it, or I have a little welder, a spot welder. I might try that here. But the moral is, at the factory, this is put on with this assembly. The whole rocker panel is a sub-assembly that just lowers in and connects the back half of the car to the front half of the car. The castle rail is put in first between the two, and then this just comes in, boom, and it's pre-assembled. So they have opportunity to weld this in correctly. When you're retrofitting a rocker panel onto a rusty car, we don't have that luxury. We have to do it in a specific order, which I've outlined, but it's basically inner sill, castle rail, medium membrane or stiffener web, whatever you want to call it, then outer sill, right? Because we have to be able to puddle weld along seams, grind them down, mate parts together, puddle weld those. So we have to go in a particular order that they don't have to do at the factory, right? As a result of that, not so easy to put this little piece in, right? But the other benefit of waiting is now I have access, and if I had a light, I could shine it down there, and it is unobstructed all the way to the front of the car, right? So that allows me to put in, snake in materials such as this, okay? Amazon special here, but it's got a tip on it that's got multiple holes in it, so you can, you know, it sprays in all directions. You can use it for, you know, lots of different things. So what I'll be doing is I'm using an elastic polymer, and then Flex Seal is an example of that. It's not what I'm using, but there's lots of roof coatings, plumbing coatings, anything that's an elastic polymer. I'm going to shoot it into this guy and just coat the whole thing, okay? So this whole outer two, because remember the sill is divided in two halves by the middle membrane, right? So the outer compartment will be completely flooded with that elastic polymer. It will flow out of these weep holes, and it will eventually clog the weep holes. It's kind of a thicker material, but I can get in, you know, through the outside and clean it up so there is still a hole here. All right, so that's not a problem. But what it will be doing, because it's not really thick, it will run down the side and it will fill this seam, right, completely. And that's the one that really gathers the moisture and just starts to rot away. So I'll be happy knowing that this seam, all the way from up here, is just filled with a rubber material. And again, then I'll punch out these weep holes so it still can drain. Similarly, the castle rail, which is your next culprit, it has its bleed holes here. So I'll be able to stick that tube up through here. I might have to make one bigger, I'm not sure yet. But just snake that up and similarly coat the inside of the inner compartment. And again, any excess will drain out of these holes, but that's good. These are big enough holes that it won't clog them, and it'll just kind of coat the edges of it. So there will be no exposed metal on the inside. And with that,
I will be happy knowing I've done everything I can to make the inside of the sill water resistant and mitigate the rust issues.
See you later. Hope this helps you understand your sill rust issues.